class we have discussed how to settle the waste layer by using the two methods. One is acid base titration, another one is a precipitation method. Okay, you will continue that. Third method is the chemical oxidation and reduction method. So you know that chemical oxidation and reduction. What do you mean by oxidation? It's a loss of electron, right? It's a loss of electron. So oxidation reduction reactions are commonly employed in the treatment of hazardous waste to transform contaminate into less harmful or inert materials, inert forms. So yeah, right? So first of all, hazardous materials are very dangerous to our human beings. So that will be converted into inert materials, right? Inert materials by using this method. This is the oxidation and reduction. Shortly we call it as a redox method. So in that, the hazardous waste to transform contaminates into less harmful or inert forms. This method implies a chemical reaction where the electrons are transferred between reactant, resulting in the oxidation. So loss of electron we call it as the oxidation. Simply we call it as. So how to identify these contaminants? The first step is to identify the hazardous contaminants present in the water stream. This may involve the chemical analysis and characterization. The only way to identify the hazardous material by using the chemical analysis and the characterization of the waste. So some of the wastes are very dangerous and very harmful to our human beings, right? So in these cases we are identifying the hazardous waste. Okay. So next, selection of oxidizing reducing agent. So we have to know the hazardous substance. Then how to rectify that problems. Okay, you have to select the chemicals or reactants. Okay, that is selection of oxidizing or reducing agent. You know that reducing agents is nothing but in favor the oxidation reactions. In favor the oxidation reactions. Okay, so depending on the nature of the contaminants, either an oxidizing agent or reducing agent is selected to facilitate desired chemical transformation. So it's nothing but oxidizing agent or reducing agent. We favor the oxidation reaction, we call it as a reducing agent. We favor the reduction reaction, we call it as a oxidizing agent. Oxidizing agent. For example, you can estimate the iron. Estimate the iron. So in that you have period solution, it's a K1F4. Then analyzed solution is the iron. Okay. Here Fe's are converted to Fe2 plus. It means oxidation reaction takes place. Loss of electron. Fe2 plus converted to Fe3 plus. Okay. So then K1F4 Mn7 plus reduced to Mn2 plus. Mn7 plus reduced to Mn2 plus. So in that place they are gaining the electrons. So here FeAs and act as an reducing agent. Reducing agent. Then K1F4 act as an oxidizing agent. That means K1F4 favor the oxidation reactions. Oxidation reaction. So here, what do you mean by oxidation? What do you mean by reduction? What do you mean by oxidizing agent? What do you mean by reducing agent? So yeah, right. So then the common oxidizing agents. It means the substance accept the electrons from the other reactants, causing the oxidation of these substances. The common oxidizing agents include hydrogen peroxide, ozone, chlorine, and permanganates. Right? Permanganates. I am saying that the example permanganates. Right? So the common oxidizing agents are hydrogen peroxide, ozone, chlorine. So these are the materials are used in water treatment plant. So you are in your home. They are supplying the municipality water. Oftenly it is smelling chlorine powder, chlorine smell. They are using chlorine powder. Okay. So here to reducing agent. The reducing agents are the substance that donate electrons to other reactants, causing reduction of the substance. The common reducing agents are include sodium borohydride, iron, sulfur dioxide, and organic compounds. Organic compounds, right? Then how to treat that process like oxidation, reduction. So you know that oxidation, reduction is a combined process. Both the oxidation reactions are takes place simultaneously. That's why they are saying combined process. Combined process. If one of the substances are donating the electron, another substance are accepting that electrons. So both the reactions that takes place simultaneously. Oxidation reduction. That means we call it as redox reaction. So in some cases both oxidation reduction process may be employed sequentially or simultaneously to effectively treat complex mixtures of hazardous contaminants. Then control and optimization. Then how much amount we can use the substance to neutralize or reduce the agent, will act as a reducing oxidation. Okay, so the treatment process is carefully controlled and optimized to ensure complete and efficient transformation. Complete and efficient. That means as hazardous elements are converted into inert material. Inert material. The efficient transport of contamination. The factors such as reaction conditions. Okay, so all the hazardous elements are going to be converted into inert materials. Okay, we just follow some parameters. One is pH, temperature, and reaction time. Dosage of reactants, mixing intensity are adjusted to achieve, right? Then monitoring and analysis. Monitoring and analysis. So throughout the treatment process, the efficiency of oxidation reduction reaction is monitored through the analytical techniques. Okay, we just monitor the that reactions are completed, how long that reactions are go, and the that content we follow by using this monitoring and the analysis. Then post-treatment stabilization, it is nothing but the reaction is completed. That means the oxidation reaction is completed. The treated waste may be undergo further stabilization or neutralization. Once again, we will go for the neutralization reactions. Okay, we check it the product. It may be having any pH content or it may be acidic or basic. We just go for reverse back to do that neutralization reactions. Then disposable and recycling. This is very important steps. Disposable and recycling. The treated waste now less hazardous or inert can be disposed of in accordance with the regulatory requirements of non-hazardous waste. It come to non-hazardous waste. So in beginning, that materials as an hazardous materials, after the treatment of redox reaction, it will be converted into this inert material or non-hazardous waste. So in some cases, the treated waste may be suitable for recycling or reuse in industry. It may be once again used as a ore material. Okay, right? After the process, right? So then the fourth reaction or fourth treatment process, it is hydrolysis of hazardous waste. Hydrolysis of hazardous waste. So it is nothing but hydrolysis is chemical reaction involving breakdown of component by the water. Breakdown. So that materials, that the components are very complicated in it, right? So we just break down to convert it into smaller molecules. Likewise, the macronutrients are cut down to smaller molecules. The same way, most of the hazardous components are very critical. Okay, so it bind with another hazardous element. So we just break down by using the water. Okay, right? The first step, identification of hazardous contaminant. Right? The contaminant present in the water stream. This may involve the chemical analysis and characterization of the waste to determine the types of concentration of pollutants. Types of concentration. First one, we just select the agents, hydrolysis agents. So selection of hydrolyzing agents. So it is nothing but it may be acid or bases or selected bases on the specific contaminants present in the water and the susceptibility of hydrolysis. Acidic hydrolysis involves the use of acids. So we are using acidic hydrolysis. For that, what the agent name, reagent's name, it's an acid. It may be acetic acid, or it may be acidic acid, or then inorganic acids like hydrochloric acid, sulfuric acid, then nitric acid. So like this acid we have to use to these hydrolysis agents, right? Then one of the basic, suppose that compounds are basic in nature, means you have to use the basic agents like the sodium hydroxide, right? It's a strong base, right? Then treatment process. So the components like your base stages are having polyethylene terephthalate, PET bottle, like drinking bottle, no? This is made up of PET, polyethylene terephthalate. Okay, so by using here the agents, acidic agents, like this is a sulfuric acid. So these compounds are break down into terephthalic acids and the ethylene glycol. So it will be easily treated. Okay, so now just look at this equation here. This is a most complicated structure. This is a polyethylene terephthalate. This is a hazardous element. This is a hazardous substance. So we just break down into smaller molecules by using acidic agents. So that's the symbol is a acidic agents. Okay, so acid hydrolysis. Just acidic hydrolysis is nothing but in acidic hydrolysis, acidic substance are added. This is acidic substance, sulfuric acid, added to the hazardous waste solution. This is hazardous waste solution. PET is a hazardous waste solution or slurry to break down chemical bonds through the addition of water molecules. So the complicated molecules break down into smaller molecules. What is that? This can result the decomposition or conversion of hazardous compounds into less toxic or more easily treatable forms. Okay, so what's the aim of this process? Is it just hazardous compounds into less toxic or more easily treatable forms? Okay, so this is one of the example that alkaline hydrolysis. Alkaline is nothing but what is that? Sodium hydroxide. Okay, so in alkaline hydrolysis, alkaline substance are added to the hazardous waste solution or slurry. So slurry is nothing but most of the complicated substances are present in that. Okay, slurry to facilitate the hydrolysis of contaminants. Alkaline hydrolysis can be particularly effective for degrading certain organic pollutants. Suppose your wastes are having organic pollutants, you just prefer the basic agents. Okay, alkaline agents, basic are alkaline agents, right? Then as usual, how to control and optimization of this process. The hydrolysis process can be controlled and optimized to ensure the efficient degradation of contaminations. And the factors, what are the factors to affecting these methods of improvement, like such as pH, then temperature, reaction time, and concentration of hydrolyzing agent. Here, hydrolyzing agent is the maybe acidic agents means it is hydrochloric acid, sulfuric acid, nitric acid. Basic agents means it is sodium hydroxide. Then monitoring throughout the hydrolysis treatment process, the efficiency of the reaction is monitored through the analytical techniques. Okay, once again just check the samples. Okay, analytical by using the analytical techniques. Then post-treatment sterilization. Once hydrolysis treatment is completed, the treated dose may be undergo further sterilization or neutralization reactions. That disposal, this is very important of this method. The last step is a disposal and recycling. That treated materials we have to use it to another purpose. This called as recycling. Suppose it is not no use, not at all. It means we go for the disposal. Okay. So the treated waste nowadays hazardous or inert can be disposed of in accordance with the regulatory requirements of non-hazardous waste. In some cases, the treated waste may be suitable for recycling or reuse in industrial process. Okay,